Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sarah Iman binti Marwan and I am from group AS1203J. So for this video presentation, me and my other two group mates will be discussing experiment 2 capacitance. So I will be discussing part 1, which is to study the capacitance vary with the separations between the plates, and to study the capacitance varies with the area of the plates. This is the data analysis for the first part of the part 1 experiment, where we obtain the value of capacitance by increasing the plate's area A0. Here, the distance between the plates D0 is constant. As we increase the area of plates slowly, the value of capacitance increases. The relationship between capacitance and area had been expressed to this graph. This graph is directly proportional, where the capacitance increases as the area of the plates increases. The theory that can be justified for these results are: the area of the plates does affect the capacitance of a capacitor. The larger the plates, the greater the capacity to store electric charge. Therefore, as the area of the plates increases, the capacitance also increases. Now we go to the data analysis for the second part of the part 1 experiment. We obtain the capacitance by decreasing the distance between the plates. Meanwhile, the area of the plates is constant here. We can see that as we decrease the separation between the plates slowly, the value of capacitance increases. The graph that we express for this part of the experiment is the relationship between the capacitance and the reciprocal of the separation between the plates. This graph is also directly proportional, where the capacitance increases as the reciprocal of the separation between the plates increases. In addition, the theory that can be justified for these results obtained are: the capacitance are directly proportional to the electrostatic force field between the plates. The field will become stronger when the plates are closer together. Therefore, as the separation between the plates decreases, the capacitance increases.
Hi, my name is Nuraza Elisha bint Azmi. Now I will explain about the effect of the dielectric on the capacitor. There are two parts, which is dielectric connect with the battery, and the another one is disconnect with battery. In this result, we can see the value of capacitance is increasing when the dielectric were inserted in the capacitor. The value of the charge and energy meter also increasing. This shown that the capacitance is directly proportional with charge. Meanwhile, the value of electric field or voltage in this part remains constant. The electric field stays the same in the capacitor after inserting of the dielectric because the applied voltage is constant. Based on the result, the capacitance is directly proportional with charge, and the voltage is constant because the applied voltage is constant. And the theory is the voltage across the capacitor has to stay the same since it is connected to a fixed voltage supply, which means that the potential before insertion and after insertion is equal. That will mean that the electric field within the capacitor is also equal before and after, since E equal to negative dV over dr. In this result, we can see the value of capacitance is increasing, but the value of voltage and energy meter is decreasing, and the value of charge remains constant. The charge remains constant because once the battery becomes disconnected, There is no path for a charge to flow to the battery from the capacitor plates. The insertion of the dielectric has no effect on the charge. The theory is introducing a dielectric into a capacitor decrease the electric field, which decrease the voltage, which increase the capacitance. A capacitor with a dielectric stores the same charge as one without a dielectric, but at a lower voltage. Therefore, a capacitor with a dielectric in it is more effective. Based on this equation, U equal to 1 over 2 Q square over C. The Q is constant, C increase, and U decrease.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ifan Ashraf bin Helmi and I am from AS1203J. So today I am going to continue our presentation with discussion, and I am going to make a discussion about our experiment 2, capacitance for part 1 and part 2. But before that, I'm going to explain about capacitance and dielectric, because these both things related to our experiment. So what is capacitance? Capacitance is the ability of a system to store an electric charge or ratio of the charge in a system to the corresponding change in its electric potential. And what is dielectric? Dielectric, it is an insulator placed between capacitors plate. Okay, so for part 1, where the experiment for capacitance, there are two reasons affect the capacitance, which is area and the spacing between plates. So for the first one, the area of the capacitor, we can use the theory that have just been told us. That is, as the area increases, the capacitance also increases. So what is the reason? So the reason is, when the larger the area of the plate, it will give us a result in more magnetic field or field flux, which is the changes collected on the plates for a given force field, that which is the voltage across the plates. And this are going to be vice versa, as when the area of the plate is smaller, it will give the result less magnetic field, field flux on a given force field. So for the both data is proven to be correct. Okay, so for the spacing of the plates, we can use the theory of, as the spacing of the plate increases, the capacitance decreases, or the spacing of the plate decreases, the capacitance increases. So what is the reason? The reason is, when the space of the plate is closer, it is result in a greater field force, which is voltage across the capacitor divided by the distance between the plates, which result in a greater field flux or magnetic field, which is the charges collected on the plates for any given voltage across the plates. And this is also vice versa, as the spacing of the plate is further, the lesser the magnetic field it will give. So that's all. So for the both data is proven to be correct. So for the second part, where the effect of dielectric to the capacitor when the battery is connected and when the battery doesn't connected. So when the battery is connected, the experiment is conducted when the battery has the voltage VO remains connected to the capacitor, and when the dielectric is inserted to the capacitor. So the potential difference VO across the plates will remain constant, but it is experimentally found that when dielectric is inserted, the charge stored in the capacitor is also increased. So when charge stored in the capacitor increase, hence the value of capacitance also will increase. And then since the voltage between the capacitors is constant, the electric field between the plates also will be constant. So for the last part is when the battery is disconnected. The introduction of dielectric between the plates will decrease the electric field. Hence, the result would be the electrostatic potential difference between the plate is also reduced. But at the same time, the charge will remain constant when the battery is disconnected. Next, for capacitance, it is inversely proportional to the potential difference. So, as a potential difference decreases, C, which is capacitance, will increases. Lastly, when the dielectric is inserted, the charge between the plates remain constant. As a result, the energy stored in the capacitor decreased. So this is the theoretical data that been collected in the explanation, and it seems pretty same with the data that have been collected in our experiment. Thus, this proven that our data is true.